Good day, we are Group 4 of ECA 113-2L, and in this video we will be simulating what was supposed to be our activity last Wednesday, which is the Lab 2-1. So can someone tell us what the objective of the activity is?
So the main objective of this activity is to prove that the data runs faster through Ethernet cables rather than serial cables. So
So to
should
do
we
that,
start with
uh,
the topology?
okay, yeah, I will be simulating the lab activity. So let's start with the topology.
So for our topology, we will be needing three routers, uh, 4331, and two PC two PCs. So for that, we will be um, connecting. We'll be first renaming it to router R1, R2, and R3 for our corresponding routers and for our corresponding PCs as well. So, so first we will turn off the router and put NIMT2T for our serial.
Take note when adding this extra port, we should be using the serial one as the serial cable will be used.
Then don't forget that after you put it to turn back the routers on so that the simulation will flow. Then next we will be connecting our um, R1 to R2 using the wire serial BGP. So we'll be using the gigabit Ethernet, the serial. We'll be using 0010 for the connection. And then we'll be using the copper cross over for connect R1 to R3. And then for R2 to R3 as well, we'll be using the same cable. And so goes on also for our PC1 to R1 and our R2 to PC2. So for
Now, let us proceed to assigning the networks of the lines and the IP addresses. So it will be easier for the addressing table as shown here.
so here on our addressing table we have the following networks 172.16.10.0/30 192.168.10.0/30 168.20.0/30 and 10.0.0.0/24 27.0.0.0/24 for our following networks. So first name the connect we will be naming the connection to 192.168.10.0/30 from R1 to R3, and then from our R3 to R2 we will be naming 192.168.20.0/30. For our R1 to R2 we will be naming it as 172.16.10.0/30. Then for our
Um, yung audio medyo mahina.
ngayon okay na.
Mahina
Better,
pa rin.
mahina pa rin. Hello.
Ayan.
Okay na. Sige. Okay, so for our PC1 to R1, we'll be naming it as 10.0.0.0/24. And for our R2 to PC2 connection, we will be having the network 27.0.0.0/24.
I'm going to arrange this briefly so it's not that messy to look at. So there we go. Now we will proceed to the addressing table. Um, to for us to easily see the connections, we can just check this show port labels, and here we go. So starting with the router 1, we have
192.
We have the IP address of 192.168.10.0/30.
30.
Then
That
for
is
our
to that is to R3. Next is to R2.
2
We have
R2, have 10.0.0
hmm?
point 1.
Ah, oh yeah, it's
Wait,
the PC. Sorry.
point 1/24.
The next is to the router 2.
To router 2, we have 172.16.10.1/30. And then we will
This port wasn't used, so there's nothing there. Next
so
is for
for
router 2.
we have 192.168.20.1/30. And then for router 2 to PC2, we have 27.0.0.1/24. Then for our router 2 to router 1, we have 172.16.10.2/30. And for our router 3, we have 192.16. Router 3 to router 1, we have 192.168.10.2/30. Then for our router 3 to router 2, we have 192.168.20.2/30. So for the net mask, for our router 1, we have 255.255.255.252. Then for the next one is the same, but the last part will be 0.
So up next we have the PCs. Let's type in there we go, 24, and the default gateway will be ending with a 1. Same applies to the PC2. So this is 10, and then the default gateway ends with 1. Then our net mask will be ending with 0. So now that we have created the addressing table, let us now proceed to the configuration of the IP addresses.
Okay, so
Let me just wait. Let me just turn off this. Francis. There we go.
So yeah, she will begin in device R1. So Nicole actually renames the host to R1, renames the router to R1, and then she'll begin with the interface G0/0/0. Then she types in the IP address command. Again, we insert the IP address and it's netmask. And then we type in no shutdown. Then it goes the same with those in interface G0/0/1. Again, IP address. This is for the PC1, of course. Then again, we type no shutdown, and then we configure the serial connection. Again, with the IP address, with the IP address and the subnet mask, as shown in the addressing table. We type in no shutdown. So we're not going to be putting anything on S0/1/1. Ideally, that should be in shutdown mode because you do not do anything with that. So let's go with R2. Again, the same process from earlier. For best practice, she renames the router to R2. Then she began with G0/0/0. She types the IP address command and inserts the IP address of G0/0/0 as well as the netmask. Then to save the configuration, we type in no shutdown. Now let's proceed to G0/0/1. This is for the connection to PC2. So again, IP address and the netmask. Then we save the configuration with no shutdown. And then we configure the other serial connection of R2. Basically, that IP address connects to the interface of R1. So that's the connection of the serial. And again, we do not place anything on S0/1/1. It should be in shutdown mode. Let's go to R3. So
wait, I typed in something wrong. Okay, here we go.
Okay, so for R3, should just configure the 2 gigabit interfaces. Again, for best practice, she renames the host to R3. Then we begin with interface G0/0/0. She types in the IP address command. She places the IP address as well as the netmask. And then save that with the no shutdown command. Also, on the other gigabit interface, she does the same thing as well. And no shutdown. So we're done with the routers. So
let us check first if if each router can ping each other. So doing this first, it's a success. Router 1 to router 3 in progress. Okay, let's do that again. Now it's successful, and router 2 to router 3. Okay, failed again. There's success. So now the routers are successfully configured. So moving on.
So for this part, she places the IP addresses of PC1. So we type in the IP address, that 10.0.0.10 on the IPv4 address. Then she places the net mask, which is 255.255.255.0. Then she finally places the default gateway, which is 10.0.0.1. Then we make IPv6 automatic. Now that's the configuration for PC1. She does the same for PC2 as well. So she places first the IPv4 address. That should be 27.0.0.10. Also with the subnet mask, the same as from PC1. And then finally on the default gateway, should be like that. And then make the IPv6 configuration automatic. So that completes the IP configuration of all the devices involved in this program.
So now that the configuration is done, let us try to ping PC1 and R1. It's successful, and then PC2 to R2. So if we try to ping PC1 to PC3, it won't work because it is indirectly connected to each other. So to easily do that, we will not be doing the configuration we've done from the last exam. Instead, we will be using the OSPF method. So I will now be doing.
So to configure it in OSPF, you will just write router OSPF1 in the router.
Wait, let us discuss first the wild mask.
hang on.
Oh, wildcard mask. So there we go.
So to get the wildcard mask, you will just subtract the net mask from 255.255.255.255. So in interface G000 of R1,
Wait, let me just
so,
type it in so it's easier. So 255. So the net mask of subnet mask 30 is ends with 252, so we just subtract that. So 0. This is 4/30. And then this is 4/24. So when assigning the OSPF, the what do you call this? Wildcard mask should follow this rule. So I will be configuring it.
okay, so the difference between the OSPF and the static is that in OSPF, you will put the connected networks directly, while in static, you will put the connections that are not connected to the router directly. So as you can see here, that's the command for the OSPF, router OSPF1, and then you will add the network's IP address and its wildcard mask. So in this case, the IP address is 192.168.10.1 and its wildcard mask 0.0.0.3. Area 0. Then you will add the next network which is the 10001.
We will
Zero,
be
zero.
following these
Yeah.
networks, so it won't be
Zero.
confusing.
And the wildcard mask 0000255 and area 0. So, and you will now add the last connected network, which is 172.16.10.0 and the wildcard mask 0000255. Hmm? Okay, so in R2, you will do it again, router OSPF1, and then add the connected networks. So 192.168.20.0 and its wildcard mask 3. Then the connected second network, which is 27.0.0.0, and the wildcard mask of 0.255 area 0. Then the last connected network, which is 172.16.10.0, and the wildcard mask 0.3 areas. So in R3, there are only 2 connected networks. So we will now add the 192.168.10.0 and its wildcard mask 0.3 area 0. The last network.
So that's the configuration of the OSPF. Now we will be testing the connection of the OSPF. So supposed to be, let's try to ping PC2 here. So P
27.0, then 0. Yeah. 27.0.0, that's 1. Right. And then
now
cluster.
It's not the 1, it's 10.
I'm sorry. Then
So tracer. There we go. It shows that, wait. It shows that it went through 4 lines or connections. So from PC1 to R1, R3, R2, and PC2. As you can see, it shows that the time it took is, wait, for ping first, it's below 1 millisecond. And when we do the tracer command, it shows that it's on 0 milliseconds, so there's no delay. So let us try it on PT2. So ping. So below 1 millisecond as well. So now let's do tracer. Oh, wait. Let's try that again. There we go. It's all on 0 millisecond. So now we will be showing that the serial port connection, when we ping PC1 and PC2, it will have how do you say it? It will be slower than using the other cable. So First, let us shut down one of the lines. So wait, please to shut down. So let's ping the other PC again. Command prompt. Okay, now it shows that it's equals to 1 millisecond. So tracer. Now it only went to R1, R2, and PC2 immediately. So you can see here, we have a delay of 7 milliseconds when it started to go through the serial cables, while the other lines, it shows that it's either 0 millisecond or at 1 millisecond. So now let's try that on PC2. Command prompt. Oh, now as you can see here, the time delay is at highest on 21 milliseconds. So tracer, there we go. As you can see, there's more of a delay than using the other cables. So now I will be showing you that the connection should still work if we do the no shutdown command again. There we go, it's up. So back to PC1, command prompt. Okay, let's try that again. It might be loading. Okay, wait. Let's fast forward it. Okay, let's ping PC2 from PC1 again after fast forwarding. So now the connection is back, back from normal. It shows less than 1 millisecond. So now tracer, it now goes from this connection. As you can see, even though there's a 3 millisecond delay there, maybe it's still loading earlier, but otherwise, as shown here, it's at 0 milliseconds, so there's no delay. So moving on to PC2, let's try that again. Ping PC1, less than 1 millisecond. Then tracer. There we go. It goes from this line again and shows that there's little to no delay. So that is all for this lab activity and showcasing the OSPF configurations. Once again, we are group 4 and thank you for watching.
Thank you.